Question 9 is an equilibrium question, and the equilibrium reaction that it concerns given with a delta H value of minus 220 kilojoules per mole. First question asks, is the forward reaction exothermic or endothermic? So our focus is here on the delta H value, and the delta H value is minus 220, which means that is an exothermic reaction. And you need to remember that the delta H is given for the forward reaction, and that's what the question asks for. So the forward reaction is exothermic. 9.2 asks whether this is an example of a homogeneous or heterogeneous equilibrium, and then to explain your answer. And the key here is to look at the phases of the different substances. In this case it's homogeneous because all the substances are in the gaseous phase. And that's the definition of a homogeneous equilibrium. Question 9.3 asks, if a catalyst was used in the reaction, what would the impact be on the value of delta H? I'm going to go back to the energy profile diagram that we used in the previous question. There's our exothermic reaction, and if you remember, the catalyst caused a decrease in the activation energy. Now delta H, if you remember, is determined by the difference on where you start, the starting energy and the finishing energy. So that's the delta H for this reaction. And you'll notice that a change in the activation energy there and there has no impact on the value of delta H. So the answer to this question is that the delta H value will remain the same even when a catalyst is added. 9.4 changes one of the conditions. The pressure on the reaction is increased. 9.4.1 asks you for the impact the change will have on the rate of the forward reaction. And so that simply requires us to answer the question, how does an increased pressure affect the rate? And the simple answer we know from collision theory is that an increase in pressure will increase the rate, because the particles are closer together and therefore there'll be more collisions per unit time, more successful collisions, etc. So an increase in pressure will always increase the rate of any reaction. In this case they asked for the forward, it would increase the reverse rate equally. 9.4.2 now asks a question to do with equilibria. This is not a rate question now. It asks, when the equilibrium is re-established, how will the concentration of NO2 have changed? To answer that question we need to use Le Chatelier. Remember, Le Chatelier says that if we increase the pressure it will shift to decrease the pressure, and it does that by going to the side with fewer moles. If we have a look at this reaction on the left hand side over here, we have 1 mole of NO2 and 1 mole of CO, so we've got 2 gaseous moles on the left. And on the right, again, we have 1 mole of NO, 1 of CO2, so we've got 2 gaseous moles on the right. And so an increase in pressure then will have no impact on the equilibrium, which will mean that there'll be no change in concentration of NO2. It will simply remain the same.